In this video, we'll talk about how to find the vertices, the foci, and the asymptotes of a hyperbola. So recall a hyperbola has the following equation: x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So let's take a look at an example. Let's say we have the following equation of a hyperbola: x minus 4 squared over 16 minus y plus 1 squared over 9 is equal to 1. So before we do anything, we should first identify what is the center of this hyperbola. So the center will be located at the coordinates h, k. So in our example, the h is the value that's being subtracted from the from the x. So we get 4, and then the k is the value being subtracted from the y, which would be a -1, because we must subtract a -1 in order for this to actually be y plus 1. So if we want to make a quick sketch of the hyperbola, the center we just found is 4, 1. Or 4, -1 rather. So 4, -1. Here's our center. And now, because the x squared term is the one that's positive, we know that the ellipse will open left and right like this. Or it will be horizontal, we could call it. So to find our vertices, remember the distance from the center of the ellipse to the vertices is equal to a. So in our example, we can see that a squared is equal to 16. So if we say a squared is equal to 16, if we take the square root of both sides, we can see that a must be equal to 4. So that means to get from the center to the vertices, we need to subtract 4 from our x-coordinate, and we need to add 4 to our x-coordinate. So if we subtract 4 from our x-coordinate, 4 minus 4, that gets us to the point 0, -1. And if we add 4 to our x-coordinate, we get 4 plus 4, which is 8, -1. So these are our vertices. And if we'd like to graph them, we can. So 0, -1, and 8, so 5, 6, 7, 8. So here are our two vertices. And now, to find the foci, we need to recognize that the following relationship exists. C squared is equal to a squared plus b squared, where c is going to be the distance from the center to the foci. So we know that a squared, that's 16. The b squared is simply the other denominator, so that's 9. So we can write c squared is equal to 16 plus 9. So that means c squared is equal to 25. And if we take the square root of each side, we can see that c is equal to 5. So to go from the center of the ellipse to the foci, we need to add 5 and subtract 5. So if we add 5 to the x value of the center, the 4, we'll get a coordinate of 9, -1. And if we subtract 5 from the x-coordinate, we'll get 4 minus 5, that's -1. So we get -1, -1. These are our foci. So if we'd like to graph that, we can. So 9, -1 would be one more out here. We'll label that F. And then -1, -1 would be right here. So here's our other foci. So we found the vertices and we found the foci. And now we just need to find what are the asymptotes. All right, let's make a little room here. All right, so I've rewritten the values that we've found so far for the center, the vertices, and the foci. Lastly, we want to find the asymptotes. So the asymptotes can be found using the following equation. Y is equal to k plus or minus b over a times x minus h. And this formula is unique to a parabola that opens left and right like this. If we had a hyperbola that was opening up and down like this would actually be a over b. So keep that in mind. So we have all the values that we need to fill in for this equation to find the asymptotes. So let's write y is equal to k, we said was -1. So -1 plus or minus b. So we said that b squared was equal to 9. So b is equal to the square root of 9, which is 3. And then a, we said a squared was equal to 16, so a was equal to 4. So we have plus or minus 3/4 times x minus h. And we said that h was this 4 right here, so x minus 4. So if we distribute this 3/4 into the parentheses right here, we can get -1 plus or minus 3/4 x. We have 3/4 times -4. So let's write that. 3/4 times -4/1. We can see that when we perform this multiplication, we could just multiply straight across if we'd like and get -12/4, which is -3. So we get -3. So now what we can do is we can say, okay, let's do -1 plus this whole mess and then -1 minus this whole mess. So if we do that, our two asymptotes that we'll get are y is equal to -1 plus 3/4 x minus 3, which can be shortened to -1 plus a -3, that's -4. So this asymptote is going to be y is equal to 3/4 x minus 4. And then our other asymptote will be -1 minus this whole mess right here. So minus 3/4 x. And minus a -3, that would be +3. So this asymptote will be equal to, we have a -1 plus 3, that's a +2. So we end up with -3/4 x plus 2. So here are our two asymptotes. And if we were to go and graph these, we can see that if we plugged in a 0 for this equation, this would be y is equal to -4. So the first asymptote has a y-intercept of -4. So it would be right here, and it would go something like this, since it has a positive slope of 3/4. And then we can see that if we plug in a 0 right here for this asymptote, we would get y is equal to +2. So the y-intercept will be +2 right here. And this asymptote would go something like this. And we already determined that our hyperbola would be opening up left and right like this. So this is what our final solution would look like. So we found the center, we found the two vertices, we found the two foci, and we found the two asymptotes, the equations of the asymptotes.